Now, let's see how we are going to determine if functions are even, odd, or neither. We like to look at this one. And from here, we see if we put the equation into Desmos, the graph of f of x will be like this. On the positive side, when x greater than 0, you have a 1, 2, 3 here. And on the negative side, when you have a x less than 0, then you have a value is negative 3. First of all, function is not defined at x equals 0. So x cannot be 0. Because if you plug in here 0, absolute value of 0 is still 0. The denominator cannot be 0. So here, that's why we say x cannot be 0. Then why on the right-hand side the picture is like this? Look, you may try f of 1, and then you plug in here will be 3 times 1, and absolute value of 1 is 1. So you have a 3. 1 times 3 is 3. Downstairs is 1. So you have what? You have a 3. You did 3, you can also do what? 2, right? So you have a 3 times 2 upstairs. Downstairs is absolute value of 2. Then, of course, these two values will be cancelled, this one and this one. So you have a 3 as well. So it doesn't matter, the value is 1, is 2, or maybe 0.5. Whatever you do, you should have a what? 3. So this basically says that on the right-hand side, it doesn't matter which value, positive value plug in, you always get y is 3. So you see here is 1, 3. Here should be 2.043, right? You can keep doing like this as many times as you wanted, okay? Now, on the negative side, it's going to be different, okay? So you see here, if you plug in f of negative 1, then that will be 3 times f of negative. And then here is absolute value of negative. So you have a 3 times negative 1 is negative 3. Downstairs you choose absolute value, so you have a 1, you have a negative 3. Okay, I did here for 1, negative 1. You may do negative 2, you still have what? Negative. Okay, so that's why I did the second point. You see here, f negative 1, 3, that's this point. You see right here. Here, yeah, it's a little bit difficult to like point this one exactly. But anyway, that will be what? This point. Okay, you click on that. And here, 1, 3, click on that. Now, so is this function odd? Of course, you see 1, negative 1, negative 3 here. 1, 3 here. If you connect it, connect those 2 points, then you see when you rotate this whole picture 180 degrees, this point goes to here, and this point goes to here. So the graph is symmetric with respect to the origin. So in this case, the graph of this function is symmetric with respect to the origin. The answer is what? This function is odd. Okay. Again, for the odd function, you should have what? You should have f of negative x equals negative f of x, right? I did here, you can see here f of 1 is 3. F of negative 1 is negative 3. So what do you get? You shall have what? Let me erase that. You shall have a negative, and then 3 is this one. Then you have a negative, and then f of 1. So it appears like negative sign here goes out. So here I did for 1. You can do for 2, for 3, but in general is what? In general, you do is f of x, you replace, if you put negative sign here, then here you should have a negative. And downstairs, you should have an absolute value negative. Okay? So, then you have a negative 3x, because this sign can go out. And downstairs, negative choose the absolute value equals positive choose the absolute value. And look, what is this? This is exactly our f of x. So you have a negative f of x. Again, what? Again, this negative sign comes out, right? Look, comes out, this negative sign. And here there is no negative sign. All right, that's the algebraic expression, and you want to do in this way with the concrete value here, concrete value here. So like here, again, I did for negative. You may also do for negative. I did here for negative. You may also do negative 2 something to check it. All right? So algebraic way and the geometric way you want to understand. All right? Okay, I'll see you next time.